Good afternoon, everybody. Good afternoon. Please confirm that you can hear me. All right. Thank you, Zoe. Awesome. Well, without wasting much time, because I may not even do the actual time that we have proposed, so we are going to start quickly, and every other person that needs to join us will join us later. All right. Welcome. Welcome, everybody. Again, it's day number 3. Lesson number 3 of our number patterns. And as you see the screen today, we are going to look at what we call the geometric sequence and series. Already from the beginning, we've established the difference between a sequence and a series. A sequence is just numbers that have a particular behavior, all right, between the terms, while a series is the addition of those terms. Okay, so before we get into today's work, I remember that we do have about 3 questions or so that we need to mark. So let's start from there, marking the homework that we had. All right, I see a lot of people are just joining in. Awesome, awesome. It would be good for them to join before we begin the geometric. Otherwise, they'll be lost. All right. Oh, beautiful one here. Beautiful one. I really love this particular question. 1 second, just to make this a bit bigger. There we go. Okay. I love this particular question. All right. It says, given that that whole expression equals to that, prove that, it's kind of crazy. But let's see how to approach such a beautiful question. The idea would be to interpret what the expression is. Once you understand the interpretation, we'll see where it takes us to. Let's look at the left-hand side. The left-hand side. I want to make sure I break it down clearly to you. Look at the left-hand side. What do you have? Let me write it out. K equals to 1. You have 6. X minus 3k, because I want you to understand. All right, what do we mean here? What is this expression? We are going to start substituting the value of k from 1 to 6, and we're going to add each of those terms. So what do we have? X minus 3. This is when k equals to 1, right? So here I'll just write k equals to 1. But because it's a sigma, I would say plus. Now, if k equals to 2, what are we going to have? So 3 times 2, what are we going to have? X minus 6 plus, what's the next one? K now is 3. X minus 9 plus X minus 396, 12 plus X minus 15 plus, what do we have? 18. We have to stop at 18. So just to put this on the top for us to see, k is 3 here, k is 4, k is 5, and k is 6. Okay, let's simplify this. How many x's do we have? 6 of them, right? 1, 2, 3, 4, 5, 6x. Okay, what will minus 3, minus 9, minus 18, minus that? What will that give us? 3, 6 will give us 9, 9, 9 will give us 18, 18, 18, that would give us 36, 36, and 27. What would that give us? That would give us what? 63. 63. We okay, everybody? Beautiful. Thank you, Divine. All right. So this is what this expression is. Interesting. All right. Now, what about the right-hand side? Right-hand side. Check. It is from k equals to 1 to 9. Do you notice it is the same expression? So I want to do something. Can I say 6x minus, let me do this first. This can be written as, please watch this, 1 to 6 plus 7 to 9. Let me know if it makes sense, because we're saying K is 1, K is 2, K is 3, K is 4, K is 5, K is 6. So if I take the first 1 to 6 together, it's that, which is the left-hand side. Oh, so this can be written as what? 6x minus 63 plus x minus. Now, I am saying K equals, I'm just doing a short form here. When K is 7, what do we have? Minus 21. When K equals to 8, what do we have? 24. K equals to 9, 27. Remember, I am now saying K equals to 7, K equals to 8. Okay, so what would this give us? 6, 7, 8, 9x. Do you want to help me with that? 63, 27 would give us what? 90. Then you have 45. 90, 45. That should give us what? Am I right there? 63, 27 would give us 90. Yep, 90 and 45 would give us 135. Minus 135. Okay. That is the simplification of the right-hand side. I hope it makes sense. So we've got the left-hand side and the right-hand, just to see where it's going to lead us. But the examiner says both are equal. So let's see. So 6x minus 63, I think from here, we can actually get the value of x, don't you see? Let's simplify. What do we have? 6x minus 9x equals to 63 minus 135. Please get me the value of x. Let's get the value of x. Now it looks like engineering maths. But it's number patterns. Yes, somebody get me the value of x quickly. 24. Yeah. This is homework. We just mark it. Oh, so x is 24. Sweet. Now, since we have the value of x, the examiner says we should show that that one there equals to 0. So that can therefore be written. Let's find, what will this be? K equals to 115. My x is what? 24 minus 3k. We need to find what this would be. Let me do this on the next page. All right, since we now know that our x is what? 24. Once you understand this, there's a short way to do it, but I don't want to start doing shortcuts right now. I want you to understand the whole thing. So let's find this expression. And we would see, what will this be? What will this be? What are we saying? We're replacing k with what? 1. Okay, so what would it be? Let me do this here by saying what? 24 minus 3. This is k is 1, right? Plus 24 minus what? 6. K is 2.
Oh, I see what you're doing.
All right, we just replace in there. Plus 24 minus 9, right? Because k is 3. That's the whole idea. So I'm doing this long just for us to see what the examiner is saying. Once you understand, you can be creative. What do we have next? 3, 6, 9, 12. Okay. Plus 24 minus 15. Plus 24 minus 18. Plus 24 minus 21. I wanted to see something. Plus 24 minus 24. That is now what? 7. Plus 24 minus 27. That's 8. Plus 24 minus 30 plus 24 minus, okay, plus 24 minus 36. That's 9, right?
Yes.
24 minus 39. Okay, this is too long. 24 minus. Okay. I want us to see if could we have done this in a shorter way though? We're gonna try. 24 minus. I think we're done. Yeah, because 15 times 3 is 45. Oof. Will this give us 0? Let's see something. Please watch. I don't want us to do the whole maths. What is 24 minus 3? 21. Is it possible to have minus 21 here?
Yeah.
Okay, hold on. This is 0, right? What is 24 minus 27? Negative 3. What is 24 minus 21?
3.
Okay, so this is 3.
Cancels.
So that cancels.
Yeah.
Okay. What is 24 minus 30?
Negative 6.
Negative 6. What's 24 minus 18?
6.
Okay. That cancels again, right? 24 minus 33? Negative 9. What is 24 minus 15?
9.
All right, that cancels. 24 minus 36? Negative 12. 24 minus 12? Positive 12. That cancels. 24 minus 39? Negative 15, because it's now a multiple of 3. 24 minus 9? 15. 24 minus 42? Negative 18. 24 minus 6? 24 minus 45? 24 minus 21? So what's our answer? Answer is 0. Beautiful notes. It's just a matter of understanding the interpretation. But this is quite long. Crazy.
Yo, sir, this is very long.
Yes, it is. It is very long. But I wanted to go this long so you understand what sigma means. That sigma means addition. All right. But let's try to cut it short. We're mathematicians now. All right. Let's try to cut it short. How would we have cut it short? At least right now you understand what's going on. Now we can play games. How would we have cut this short? Let's see something. Let's create a fresh page. How would we have cut this short? Do you want to give me you want to do a trial? Because this is what I would have done. Check this. I would have done this. This can be written as k equals to 1 to 15, 24, no, 1 to 9, k minus 3k, then, what will this be? 10 to 15, 24 minus 3k. This is what I'm thinking in my head. 1 to 9, 10 to 15. 1 to 9, 10 to 15. Yes. Cici, I didn't see that name. 1 second. Is that Cici's Cici's hand was up. Cici's your hand was up. Was it a mistake? Okay, Kwesi, what do you want to say?
Sorry, sir. How did you get that last what is it? 15 element k equals to 10.
Now remember, I started from 1 to 9. It's 1 to 9. Then the rest will be from 10 to 15. It's a way of just breaking it up.
Okay, so you say 1 plus 9 will give you k equals to 10.
Huh?
I'm not sure.
Remember, it's 1, 2. This one means 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, 11, 12, 13, 14, 15. Now you break that up. So 1 to 9, 10 to 15.
Oh, okay, makes sense.
I just want to see if we could make it shorter.
Okay, thank you, sir.
Could we make it shorter? But the examiner really wants us to expand. But there's nothing we can do. We have to get x as 24. Remember, we have to start from here. We have to start this one. There's nothing you can do. We have to get x as what? 24. The shorter way of doing this one would be to do this. Okay, let me do everything. I want to try to see if I can get it shorter. I want to use that same method I just wrote now. 1 second. All right, let's try to see if we can do it shorter without doing all those expansion. Check. K, that x minus 3k is equal to, if I then do this, what I explained earlier, because it is 1 to 9. So I'm breaking it into 1 to 6. From what? 7.
Oh, yeah, 7.
7 to what? 9. I hope that makes sense. That is 1 equal to 1 to 9. But we are told that they are equal. What do you notice? It's like moving it over to the other side. The whole thing expression is the same. So what does that give me? That gives me that what? Sigma from 7 to 9, x minus what? 3k should be equal to what?
That's to be 0.
Wait, okay.
No, you're not, those two cancel out.
Because these two cancel each other, so 0, therefore, to 9, x minus what? Beautiful. Now, this we have to expand. So if we expand this, what do we have? X minus 3 times 7, 21. What about 8? Come on, no, 3 times 8, 24. I'm going to show you something now. 27 equals to what? 0. What do we have? 3x, 21, 24, 45. 45, 27.
7.
Just hold on, guys. 21, 24. Just give me an answer there quickly. 72. So what is x? 24. All right. Can you please hold on, Crazy? What's the story? Crazy, okay, talk.
Sorry, sir, you got me lost there by x minus 21 plus x minus 24. Please explain on how you got those values, sir.
How did we get 21? We said we are now starting from 7. K equals to 7 here. Anywhere you see K, put a 7.
Yes.
Here, K equals to 8. 3 times 8, 24.
Makes sense. Okay.
That's what sigma is. You just keep substituting. So Kx equals to what? 24. But now I want us to do it in a very simple way without doing the whole of that. That is an arithmetic. I don't know if you notice. Hold on. They said sum to 15 terms. Sn equals to what? N over 2. Make sense?
So you can't use that.
So what is my n? Top minus bottom plus 1 would give me what? 15. What is my a? A is the first term, right? Which is x minus 3k, which is what? 24 minus 3, but my k is what? 1. What would that give me? 21. What is my last term? X minus 3k. What is my x? No, x is still 24. But what is my last term? 15. What would that give me? Negative 21. Bring all of that in. S15 equals to what? 15 over 2, 21 minus 21.
So that's the easier way.
Done. Yes. I've got 3 hands up. Nikki says slow down. Okay, what's the story? Am I on fire? Okay, okay, I'm calm now. Okay. All right, let's take it one by one. Chuku, Shabalala, talk to me.
Sir, so now the way in which I solved for the first part, right, is that I first equated the two formulas as given in the question. Then I found T1 and T6 and also T9 based off what we have, right?
Okay.
And then from there, I just said that Sn for the first sigma will be equal to Sn for the second sigma. And then I just substituted the values that I got. And then from there, that's how I got x equals to 24. So I just wanted to know whether I'm okay with that method.
Perfect. Let's do it again. Let's go that way again. As long as you see, I'm trying to accommodate everybody thinking here, but what I don't want us to do is to do the first thing I did. The first thing I did was manual. I don't want us to. Guys, don't forget, what does this mean? Sum. So, fine. If we were to simplify this, we're going to just make sure everybody gets this. X minus 3k. What does this mean? It means sum. We can use what? Sn equals to what? N over 2 a plus L. What is our n? 6 minus 1 plus 1, top minus bottom. What is our a? X minus 3, but k is what? 1. And what would that give us? X minus 3. What is the last term? X minus 3, the number on top. What's your answer? X minus 18. Right. So what is S6 going to be? 6 over 2 x minus 3 plus x minus what? Do we agree? A plus L. All right. Let's simplify this. Oh, this is 3. I'm writing 6 over 2. 3 2x minus what? 24. Left hand what? Side. Okay, together. Let's move. Right hand side. So once you understand the concept, you have confidence to navigate through and through and through. Nikki, are you okay now? Nikki, are you okay? Nikki says slow down. All right. Let's interpret. What does this expression mean to us? Again, it's a sum, right? So what is our n? 9 minus 1 plus 1. That gives us 9. What is our a? First term. Anywhere you see k, what do we put? 1. What do we have? X minus 3. What is the last term? X minus 3. Top is what? 9. X minus 27. So what is Sn? S what? 9. Should be equal to what? 9 over 2 into bracket x minus 3 plus x minus 27. What will this give us? 9 over 2. Let's leave it like that. What will that give us? 2x
minus 6.
All right. If we want to do math here, do you notice we can factor out the 2?
Yeah.
I want us to be smart. Let's start preparing for MBT. Do you see that? It's now simplified, right? What do you have? 9 into x minus. But the examiner says the left-hand side is equal to the right-hand side. So let's equate. See, I think sometimes we are afraid that am I doing the right thing? As long as your mathematics is in place. All right. Okay, let's see. Somebody's raising a hand. Yes, Chuku.
Sir, isn't the minus 3 minus 18 supposed to give us minus 21?
Which one? Oh,
minus 3
21.
minus 18.
Yeah, minus 21. Minus 21. Okay. Do you notice we can find x now? I don't even want to expand. Divide both sides by 3. What would that give me? 2x minus 21 equals to 3x minus 15. So 2x minus 3x. We're in grade 12 now. Skip some steps. What do we have? Negative 45 plus 21. Wait. What are we getting?
That's equal to 24, yeah.
No, but this is 21 minus 45. What did we do wrong?
No, it's negative.
Oh, negative x equals to negative what? 24. I don't know if it makes sense. Sigma means sum. Once you see, a learner who doesn't really understand how to use the formula will be doing it like this. I want you to see the time it took. This is manual. Oh, where is it? This is manual. You're breaking it down. But if you understand what the breakdown is, you can start understanding what the formula and appreciate what the formula will do. So you start substituting the value of k. But since we know it is sum, we don't need. Look at this is too long. But I did this for us to be able to see what's going on. This is too long. This is genius. I want you to see how I broke this down. Look at what I did here. I broke this down. The examiner says from 1, where's my highlighter? From 1 to 9. 1 to 9 can be broken down as 1 to 6. What am I left with? 7 to 9. We must learn this. This is very, very important. I think this year, under functions northwest, functions northwest, they brought in sigma under a parabola. No, it was in paper 2. It was under analytical geometry. Yeah. But I can screenshot it to you. I remember it is Northwest 2024, question 4, paper 2. Yes. So they gave a circle, and they said a circle is not a function. First, they said convert it into a function. Then now use sigma. Beautiful. Somebody's already crying. Guys, we're going to walk through. That's the whole idea. We're going to walk through. But I don't know if this makes sense. All right. So I broke it down. Why did I do 1 to 6? Because I see this. So that this, if I move this over, whatever this value is the same as this value. That gives me what? A 0. Then I have k. I mean, opening 3. It's not that much. I get my k x as what? 24. Then I move to the right-hand side. What does this mean? It means what? Sum. First term and last term. N. Top minus bottom plus 1. What is my A? I'm starting from k is 1. So anywhere I see k, put a 1. The last one, 15. What do you have? 15 there. Perfect. Can you see that? 21 minus 21. It goes away. All right.
It's one of the more easier questions.
Yeah, it's just tricky, you know. The appearance scares you.
But once you understand the concept,
The idea is to start and don't give up until you get to the end. Because you look at it and say, oh, I don't even know if I'm on the right track. Just continue. Let's see. Yes, I actually did that question online. You know, this year. I was supposed to be doing it last year. I did it when we were preparing for finals. Guys, did this one make sense? This is just repeating the same system throughout now. All right, sum left-hand side, sum right-hand side. We are told they are equal. X equals to what? 24. Once you get x equals to 24, what do? You bring this part now in. You bring that little part and add it to that, and you're done. 5 marks.
The first way you show us this, then you show me.
Yeah, you can't be doing manual things. Imagine if they say from K to what, 50. K equals to 1, K equals to 2, we don't want to be doing manual stuff. All right, guys, would we have to conclude by saying left-hand side equals to right-hand side? No, you're not concluding anything. They said proof that that is equal to 0. So this only allows you to get the value of x. X as 24. Now you'd come here and now simplify this one by now saying that k equals to 1 to 15, x minus 3k will be equal to what? S15, which is what? 15 over 2, 21 minus 21. But you need to show us how you got the 21 and negative 21. You're done. Remember, that's your A. Okay, let me just put everything here. Let me redo everything here. What is our A? X minus 3k. But our X is what? 24 minus 3, which is what? 21. What's the last one? X minus 3. And I want to show the substitution so that if somebody's K is 1, 3k again. 24 minus 3. What is our K? 15. And that will give us what? Negative 21. So S15 will be what? 15 over 2, 21 minus 21. And that will give us what? 0. Are we okay, everybody? Did it make sense? Even this one looks long. Check the whole answer here. Can you see this one is a bit shorter? That's the whole thing. Check this learner. This learner has wasted time. Oh my God of heaven. I didn't finish my paper. It's because you are doing things like this. But it's good because at least, you see, if you understand the behind the scenes, it makes life a lot easier. Once you understand the behind the scenes, things are going to be quite easy. Are we okay, everybody? Did it make sense? Can I give you a secret? Your teachers are keeping this for a test. They're going to, trust me, you'll come back and tell me that, oh, yeah. And don't cram it. Because if you cram, you know what's going to happen. You will sit and say, what did we do? No. Understand it and be able to reproduce it. That's the whole idea. All right. Are we okay, everybody? Can I get your thumbs up? We're starting on a very high note today. Okay, beautiful, beautiful question. Beautiful question. Let's say this one. I don't think this one is difficult. Consider an arithmetic sequence which has the second term 8. I've told you this. Change the English into what? Maths. Second term is 8. What do we know? T2. And what is T2? It's arithmetic. A plus D. You have your first equation. Then what do you have? T5 is what? 10. What is T5? A plus 4D. Are you seeing that this is now basic simultaneous what? Equation. Always learn to change. Once you don't change, you're looking for trouble. Do you notice like I'm getting 2 answers here now? I'm getting both my A and my G. But that is even too long. Look at the examiner says common difference. I could have said, since I'm looking for common difference, T5 minus T2 is 3D. What is T5? 10. What is T2? 8. All right. So what's our answer? And somebody thinks if I get a fraction, it's wrong. Let's see if we're going to get 2 over 3 here. Simultaneous. Can we eliminate? Do you guys still remember how to eliminate grade 10? I know in grade 11 you were all doing substitution because it's a quadratic. So A plus D equals to 8. A plus 4D, just subtract. A minus A would give me what? 0. What is D minus 4D? Negative 3D. What is 8 minus 10? So what is D? And from there, can I get A? Okay. Why do I need A? The examiner says I should write this as what? Sigma. Remember sigma, what comes in here? Tn. And I know the first 50 will start from 1 and end at what? So I'm still going to need to get my Tn. But do you guys remember? Okay, let's find A. What is A? What do? We just substitute, right? So A plus 2 over 3 equals to 8. What is A? That will be 8 minus 2 over 3. That will be 24 minus 2, which is what? 22. Do we agree with my 22 over 3? You may use a calculator to confirm. Please confirm.
Oh, you just said 8 times 3 over
You know, we must learn those little cheats, you know. It's 8 minus 2 over 3. Make them of the same denominator. Grade 8. So it's 24 over 3. So you have 22 over 3. NBT. Start learning NBT processes now, guys. That's how we do NBT. Okay, what is my Tn, by the way? I'm sure we can get Tn. Remember Dn? If you remember that. So what is it? 2 over 3n. What's our A? 22 over 3 minus 2 over 3. Same denominator. What do we have? 20. So what is my sigma? We are done with that question. Sigma 2n. Please put everything in the bracket. 2 over 3n plus 20. But what is your n? Where are we starting from? 1, 2, 50. Yes, talk to me, Kwesi.
Sorry, sir. How did you get 20 over 3?
A minus D. What is your A?
22 over 8.
Over 3.
Oh, sorry, over 3.
What is your D?
2 over 3. Oh, I see. Thank you, sir.
All right. Guys, are we together? Are we okay? Is it making sense? Determine the sum of the 50. Let's do that on top. Sum of the 50. We're looking for Sn, right? Number 3. Sn, can we just use this one? What is N? 50. What is A? 22 over. What is the last term? What do? We sub in what? 50. 100. 120. 40. Come on, you lost your mojo now. Okay, so what do we have? S50 will be equal to what? 50 over 2. What's our A? 22 over 3 plus what? 40. Give me an answer there. 120. Yes. 3550 over 3. Nikki says 355. Confirm? Guys, let's leave it as just fractions. Let's do it as fractions. Fractions are always a better way of doing stuff. Everybody okay? We're good? Guys, please don't relax. Don't say it's holiday. Look for questions now and expose yourself. Just 2-3 questions. I mean, you have 24 hours. You can't be telling me it's holiday, you're resting for the whole 24. Your brain would even go to sleep mode. You become passive. Can't say 24 hours sleep, games, TV. Don't you get bored of those things? Do some maths. Give your brain some.
On the next page is it today, which one must we do first?
24. All right. I think we have one more. Ooh, this is beautiful. We did something like this. The first 24 terms of an arithmetic sequence are that. Calculate the sum of all natural numbers from 35 to 100 that are not divisible. If you remember what we said, S total in a sample space will be S divisible plus S not divisible. What do you notice about the sum they gave us? 35, 42. Those are multiples of 7. They're all divisible by what? 7. Okay, so, but how many terms do we have? If we look at that, what's our difference? Okay, let's put a minus there. What's our TN? 7n minus? Oh, plus 22.
No, that's 35 minus
28. So what is, how many terms do we have here? 7n plus 28 will be equal to what? 196. Oh, the product is 24. Okay, anyway, I'm not going to waste my effort. What is 196 minus 28? 196 minus 28? You sure? That will give us 8, 7, 2. That's now what? 8 to 6. Okay. If we divide, how many times will 7 go in 16? 2, 14. You have 24. All right. They told us this already, so it's fine. Can we find the sum of this? This is what happens when you don't read. Sn would be what? N over 2, A plus what? L. So 24 over 2. What is our A? 35. What is our L? 196. Please get me an answer for this. This is the sum of numbers divisible by what? 7. Numbers divisible by what? 7. Okay. Let me do this. Okay, S24. This is what? Divisible by 7. S divisible. Now let's look for S of natural numbers. Again, we can use the formula. What is your N? How many natural numbers are there from 35 to 196? Don't forget, top minus bottom plus 1. What is 197 minus 35? 7 minus 5 would give me what? 2. 162. What is our A? 35. What is our L? 196. Give me an answer. We did one like this that says divisible by 5. So it's the same thing.
They say natural value. You just take the plus one.
It's all the numbers. You're saying 35 plus 36 plus 37 plus 38 plus 39. All the numbers.
No, I think we get our N.
Top minus bottom plus 1. It's like saying numbers from 5 to 8. Somebody will say 8 minus 5, they are 3, but you just lied. If I write it out, it's 5, 6, 7, 8, they are 4.
Okay, the plus one comes.
That's where the plus 1 comes in. All right, sum of numbers not divisible by 7. What will it be? 18711 minus 2772. Huh? No, it can't. It's 18,000. No, it can't. It's 18,000. 15939. Thank you. Answers are coming in. 15939. All right, let me ask, are we all okay with this, what we've done so far? Because I think that's my last question. Yeah, that's my last question. So far, are we okay? Arithmetic? Please go through your notes again. Get as many questions as possible. Whatever you've learned, put it into work again. The questions will be different, but the principle will remain what? The same. All right, let's get into something you haven't seen. Something very new. Geometric sequence. New, completely new. We touched it in grade 8, but you don't remember. Geometric. What are the properties? Oh, before I go there, what are we going to look at? Before I go there, let's look at. This is what we're looking at, 4 things. Introduce ourselves to geometric sequence. Then we go to geometric series. Then we look at sum 2, infinity, then convergence rule. Sigma notation will be exactly what we've done here. So basically, we're looking at 3 things. Please follow through. I want to be done with content of this one today. Geometric. What is peculiar about the geometric sequence? What are the characteristics of a geometric sequence? The main thing here is it has a common ratio.
Oh, it's this one.
Yeah. That is T2 over T1, common ratio R, will be the same as what? T3 over T2, which will be what? T4. Okay, can we say Tn over? It is not a difference now. It is what? A ratio. We divide. We divide. It's going to be a ratio. Are we okay? Arithmetic is a difference. This one is a ratio. So that is point number 1. Point number 2. Our T1 will still be A. Just like arithmetic. T1 will still be A. Number 3, which is the final thing. Tn is A R to the power n minus 1. A multiplied by R to the power n minus 1. That is the basic introduction. It is a ratio and not a difference. But I'm going to show you certain questions. Examiners are going to put both of them together. Yeah, they just created. In fact, I've seen questions where they said that the first, second, and third term of the arithmetic is the same as the first, second, and third term of the geometric. Crazy stuff. We just interpret, so don't lose the basic things here. Okay.
Is this the one where like T1, T3, T5 is the same, and then T2, T?
That's another way of setting the question. Okay, that's another way. Okay, quickly before we go on, what about multiple ratio? We did multiple difference. Remember T5 minus T3 and whatnot. Let me try to prove the multiple ratio for you. Or let me write the formula first. Tk over Tm will be equal to R to the power K minus n. Example. T9 over T3 will be equal to R to the power 6. There are 6 ratios. Just like the way we did multiple difference. and then you can find the sixth root. Okay. Please note, once I introduce an even root, my answer must be plus or minus. Please, that is very, very important. If it is an even root here, but if it is an odd root, my answer will always be positive. We're going to look at let's start with very, very simple, basic examples, Just a moment for you to write. Simple, basic, straightforward example. We don't want to cry. Please note the difference between ratio and what? Difference. Okay. I've got a t-shirt where I wrote, yes, if I remember the statement. The difference between arithmetic and geometric is ratio. Look at the way I interpret it. The difference between arithmetic, this one goes with this. So one of my t-shirts, I had to print it. The difference between arithmetic, so I know that difference is arithmetic and geometric is what? Ratio. So once I say geometric, you said that last statement is the key. Geometric is, think of it as a statement on its own. Forget about the rest. Think of it as a statement on its own. Geometric is ratio. Then you're done. Because learners mix them together. Once you mix them together, you know what's going to happen? You're going to mix the formulas. Once you mix the formulas, I forget the whole thing is the mess. It's a big mess. Okay, let's look at an example. Are we ready? Sometimes they don't. You've got to test it out by finding. So there are three things. First, you find difference. If that doesn't work, you check for ratio. If that doesn't work, you check for second difference. That takes you back to quadratic. So those three patterns will be tested in grade 12. Let's see something here. Do I have something simple? Great. Can I ask you to try this? Yeah, just try it. Let me push you out. This is grade 12. You're no longer in grade 10. Where we spoon feed you. I'll just write the formula for you here. You'll be given that formula. The formula is what? Tn. Let me see what you can do. Is A multiplied by R to the power N. Just try it. Let's see. 5 minutes. Just try. If you don't get it right, I won't crucify you, but I might. Okay. What a guan. Let's just see. You just try. Haven't listened to what I explained. Ratio T2 over T1, you're done. Ooh, let me. Yeah. You're done. Simple. Yeah, it's crazy maths. Crazy maths. All right, guys, tell me you were able to do this. What's your common ratio? Let's take it together slowly, slowly. I really put you at the deep end. Number one, what is your R? T2 over T1. What will that give you? 2 over 3. You were done. What do you notice about K? There are two ways. You could just multiply. Look, I could do this. K will be 2 times 2 over 3. So just multiplying. Or you could do this. Use the formula. What is Tn? We said Tn equals to what? A R to the power what? N minus 1. What is our A? 3 multiplied by, what's our R? 2 over 3 N minus 1. Now, what is K? K is the third term. What do you notice? 3, 2 over 3, 2 minus 1, which is 1 there, right? Wait. What did we do wrong? Oh, it's 3 minus 1. 3 minus 1, which would give me what? 3, 2 over 3 what? Squared. Make sense? No, 4 over 3, because 3 and 9. All right. I hope you're good there, guys. Just to show you how things work here. Look at the last one. Calculate the value of what? N. If Tn, simple now. Do we know they said Tn is 128 over what? 729. What is our Tn? What's the formula? 3, 2 over 3. Please, I'm going to quickly tell you what you should not do. And this is where learners are going to get into trouble. Please, don't do this. Let me write it here. You have 3, and some of you actually did that. Please, you cannot do that. Some of you did that. No, no, no. Laws of exponents. Please, that's the tricky part here. You cannot do that. So what do we do here? Divide both sides by what? 3. What do you have? 2 over 3 n minus 1. What will that give us? 2187. I don't know if you guys were able to do this. You know what you can do here is to make sure both are of the same what? Base. Please go back to your laws of exponents. All right? So 2 over 3, I'll show you 2 methods here. Can we write 128 as a base of 2? Use your shift fact. 128, I don't know if you guys know how to do that. Okay, my own calculator doesn't have that button. The one that has, it's so small. Do you know how to do that? 128 equals to shift fact. You turn it into exponent. It works. It should work. It works. Okay, let me see my screen if you can. 128 equals to.
Oh, you need step by step.
Then you press shift, the fact button, F-A-C-T. 2 to the power 7. Did you guys get that? Let me know if you got that. If you didn't get that, I need to take it slowly. 2 to the power what? 7. Can you do the same thing for 2187? It should give you 3 to the power 7.
Yes.
And now, because they have the same exponent, I could write it as 2 over 3 to the power of what? 7. Same base, what do I do? Equate the exponent. What is n? Let me quickly teach you something here. Are we okay, everybody? Are we okay then? Are we okay? Let me quickly teach you something. My learners would know this, so but let me bring you up to speed with something here. Quickly, just we take a diversion. Finding exponent variables. Finding exponent variables. You're going to need this when we get to financial maths, but I want to teach you now. Finding exponent variables. If a to the power x equals to b, then x can be written as what? Log of base a, b base a. Some of you have never used that thing before, which is the same thing as log b over log a. I'm going to show you today. You're going to learn something new. But write that down first. This is how you find exponent, that a variable that is an exponent. If a to the power x equals to b, then we can find x. We're going to do this again under functions. This is you changing an exponential, and that's the only thing in grade 12 under functions. Exponential and log functions. That means if you do your functions very well in grade 11, functions in grade 12 is 1 day. It's 9 marks. Just 9 marks. Yeah. All right. So this works with exponent. Let's prove it. Let's use something that we know so that we are rest assured. I want you to have confidence in this, and I'll show you how to use this on a calculator. All right. If I tell you that 2 to the power x equals to 32, grade 8, what would you do? 2 to the power x is 2 to the power 5, right? Equate the base. Since the bases are equal, equate the exponent. Okay, let's try it using logs. 2 to the power x, please listen carefully. You only use this when the variable you are looking for is an exponent. Let's drop x, log. This 2 here is a base. When it comes here, it must come and remain as what? A base. Then you have what? 32. Look at my calculator, my beautiful learners. Please grab your calculator. The log, there are 2 log buttons on your calculator if you check. The one on the last side, the right-hand corner under on, press it, you must have that. I'll give you a moment. Find it. Find it. Now you have 2 boxes there. The lower box, what do you press there? 2. The upper box, what do you press? 32. 5. Let me know. Just put a condition here for me. B must be greater than 0. Did that work? Did that work? Some of your teachers are going to prefer to do this. Look at what I'm going to do here. I'd say log 32 over log 2. I'll be using a different log button now. Please go back to your calculator. There's that one that is just written log. So we are divided. It's called natural log. You'll also use this. Oh, some of you did this under acid and base.
Yeah.
pH. Yes. pH. Log 32 over log 2. Check your answer. 5. Are we good? So we use this when you're looking for what? Variable that is an exponent. What was our variable? What did we have earlier? 2 over 3 n minus 1 equals to 128. All right, so I could have done this. Which one is the base? 2 over 3. Throw the number here. Okay, let's do it together. Get a calculator. I'm using, you can use anyone you want now, right? So, but let's use this one. 2 over 3, close bracket. What do we have there? 128 over, was it this one you used?
Yeah.
7. So n minus 1 equals to 7. Guys, are you okay? Are you learning something new? Are we learning something new? All right. Did that make sense to you? Awesome. Beautiful. Beautiful. Let me just do one thing before I give you another question to try. Okay? Just to explain one more concept. Not really, just to expatiate on, because I know that if I don't mention it, some of you might get lost with it. All right. What did we say Tn is, everybody? We said Tn equals to what? A to the power that, right? So what is T1? 1 minus 1. That is A to the power, and anything to the power 0 is 1, which is what? A. What is T2 going to be? AR to the power 2 minus 1, which will give us what? Good. What is T3 going to be? 3. What will this give us?
Yes.
All right. What do you think T4 would be? Can I jump?
Yeah.
AR to the power 3. What is T5? 4. What is T6?
Yeah.
Are we okay there? So take note. Now, my dear learners, what do you think T10 over T2 would be? Multiple ratio. I am now giving you the 10th and the 2nd. What is T10? AR to the power 9. What is T2? Okay, do you notice the A would cancel? So what do we have? R to the power 9 over R to the power 1. What's your answer? So T10, that's where I got my formula that says, oh, TK over TM would simply be what? Multiple ratio. So the examiner is giving you the 10th and the 15th. Just divide and know that, you know.
So you can skip it all along those systems, but we just say 10 minus 2.
Yes, let's try it. The question we just did right now. T8 is 128 over 729. Do you remember? Let me go back. Let's use the same question that we just did.
Yes.
Oh, no. I think I'm on the wrong side. I'm going the wrong direction. T8. What is T2? 2. Let's find R. T2 is what? 2. What is R? I'll just come and say T8 over T2 is what? What is 8 minus 2? Okay, so what is that? 128 over what? 729 divided by 2. Okay, give me your answer there. 64 over 729. I don't know why I'm done. 64 over 729.
Yeah. Oh, yeah. I know. Yeah.
Okay, now how do I get my R? R becomes what? The 6th root, but plus or minus, because it's even. 64, let me write it nicely. I don't like my root. Of what? 64. Please don't use logs here. Some of you are just going to be using logs now. Anywhere you see something you don't know. No. Logs are only used when you are looking for a variable. All right. 6th root. You got over 3, right? 64 over 729. 2 over 3, plus or minus 2 over 3. So if they want you to do this, they'll give you the restriction. Say R is greater than 0, R is less than 0, or the 30 possible values. So it's either plus or minus. Guys, are you okay? Are we okay with this? Did this make sense? Let me know. Let me know. So this is my introduction to geometry. Not bad at all. We're going to add as well. We did some of arithmetic, right? We're also going to do some of geometric. But before we do some of geometric, I have a question for you. Let me see what my next question is, if I have covered the concept there. Almost. Oh, the rest is sum. Because this is baby stuff, you know. The rest is sum. All right, but before I go to the sum, look at this. Consider, I'm going to write this question. Consider the geometric sequence I wrote it down. I was thinking in my head. 5 m minus 1 over 2, 2m minus 7 over 4, 1. Find the value of m. 2. Find the value of the 17th term. Please, you may start. And number 3. Which term has a value that I need to quickly calculate? Bring me a calculator there. But start. Thank you. Let me make this easy. 7th term. Here. Let me give you a hint for the first one. Once you see questions something like this, use common ratio. T2 over T1 equals to what? T3 over. That's the way we're doing arithmetic. Say T3 minus T2 equals to what? T2 minus T1. Same story, and then you solve. Let's try. Hi guys, did you manage? Give me your responses quickly. Give me your responses. Did we manage? May I please get responses from us?
For question 3, you rounded that up to 4 decimal places.
No, that was the answer it gave me when I tested for question 3. Okay, let's see. Let's see. For the first one, what would you have done? T2 over T1 is T3. That's how it works. What do we have? What's our T2? M minus 1 over. I know the problem is this division. So please, if you are not sure, look at what I'm going to do. Divided by 5. What is T3? 2m minus 7 over 4 divided by what's T2? Be very meticulous about this. What do you do now? You flip that. What would this be? 2m minus 7 over 4 times what? 2 over m minus 1. Okay, what would this then give us? M minus 1 over 10, because you're multiplying numerator and numerator, denominator and denominator. What will this give us? Can I do that? Is that fine? So what will this give me? 2m minus 7 over 2 into bracket m minus 1. Can we then cross multiply? What do we have? 20m minus 70 m minus 1, right? Okay. 20m minus 70. What does this give us? M squared minus 2m plus 1. 20m minus 70. Am I right? Are we fine? Yeah, we good? What does this give us? 2m squared minus 4m. You see, we start doubting ourselves sometimes once you are working. Okay, so this is going to give us a quadratic, right?
Yeah.
So what do we have? 2m squared minus 4m minus 20m plus 2 plus 70. I've moved everything over. So my 20m and the 70 signs have changed. What do I have? 2m squared minus 24m plus what? I can divide by 2, make life easy. Oh, great. What do I have? M minus 6. Ah, sweet. What is M? 6. Did you get 6?
Yeah, what about using plus multiply?
Yeah.
But then I just times the thing here by 10. 5 minus 1 over 10, I just times the other side by 10.
Yeah, it's fine. The same. Next principle. Guys, talk to me. Are we okay? All right, no, let's walk through it together. I'm trying to save time. There's a lot of questions, guys. You cannot finish the grade 12 resources. Yeah, it's too many. So once we do this, you can now, start applying yourself. M is 6. But the best thing is to change my pattern now. So let's change the pattern. What would the pattern be? It should be, so my new pattern will be what? 5 over 2, 5 over 4. I hope you understand how we got the 5 over 4. We just replaced 2 times 6, 12, minus 7, 5. All right. Can I get R? What is R? T2 over T1, which is what? 5 over 2. Which will give me what? You know what I do? Let me show you something that I do. It's very crazy though. Divide the numerator. What is 5 divided by 5? What is 2 divided by 1? All right, MBT. NBT. NBT. You can test it. Check this. Let's use a very simple one. That should give us 1. 2 divided by 2. 3 divided by 3. Okay. Just some crazy stuff. All right. My R is what? Half. We're good. So what is our TN? Formula is A times R to the power what? N minus 1. So what is my A? 5. What is my R? Half. Now the examiner wants what? T? 7. What's your answer?
5/62.
Are we okay? Are we okay? 5/64. Now, the last one, I don't know if I just created this question in my head. What is that value? 298023. So TN is
29802.
okay, 1 second. TN is 298023, comma 229. All right, so we know what our TN is. What's our TN? 5 into half n minus 1, 298023. Okay, what do we do? Let's divide both sides by 5. So what do we have? Half n minus 1. Now, do you notice there's no way I'm going to use shift fact for this one? I hope I did. No, I'm wrong. I'm wrong.
Yeah, that's the limit.
Yeah, I'm wrong. I'm wrong. Sorry, I just realized what I did now. I said my ratio was 5/2.
Oh, that's
Sorry, my bad. Yeah, I just realized what I did now. What a big mess. That's why I'm going to struggle there. So let me just correct that value. But I still want to use a decimal. I still want to use it. Sorry about this. 0, comma. I'm not serious. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You know why I want to do this? Some of us see it and say, what type of a question is this? Wah. We never see this. 1, 2, 3, 4, 5. Yeah, 9, 5, 3. Examiners will always want to scare you with the question, you know. Okay. Okay, give me that value again. It's how many zeros? 5 zeros?
yeah.
Then what?
95367.
Okay. So 0, comma 0000953. What do we do? We can divide that by 5, right?
Yeah.
So if you divide, what do you have? Divide that by 5.
0,5 zeros. Then 190,734.
Now, can we use logs? Let's try logs now, because I wanted us to use logs, you know, that's the whole idea. What would it be? Log, what goes to the bottom? Half, right? I need to teach you something on log, but for now, I hope this just works. What's your answer?
19.
19.
Yeah. I will answer plus the one and bring the screen.
So this should be 20, right? That's the whole idea. That's what I wanted to. No. Is it not 18? This whole thing should give you 18. Yes, talk to me. Crazy.
Sorry, sir, how did you get those decimal values?
Which one?
0,00 and the 95, all of those decimal values. Sir.
Question, Crazy.
Sorry, sir.
That's the question. Look at question 3.
Oh, okay. And
All right. Your final answer is 19.
Final answer is 3.
Oh, okay.
The log is 19 plus the 1 is 3.
All right. So Crazy will divide both sides by 5.
yes,
So
sir.
what would this give? This give us 19.
19.0, yeah, it's 19.
So the idea is to quickly introduce you guys to how to use logs. Don't be scared of the question. Just know the principle. When do you use logs? When you are looking for a variable that is an exponent. Let me know if this makes sense, guys. Let me
Sir,
know. Yes.
sorry, how did you get with that value 0,000953 and then the other decimal value?
Crazy, this is the question. Read the question number 3. Which term has a value of 0,000953674?
Yes, sir.
That's the question. So what do? Divide both sides by 5. Divide by 5. Divide by 5. That will lead you to 190734. And now you can bring in your logs. Yes?
Okay. Thank you.
You're okay now, right?
Yes, sir.
Okay. So the question, I wanted you to feel intimidated with the number of zeros. And that's what the examiner would want to do all the time. To intimidate, okay, what am I going to do with these zeros? No. Since I am looking for an exponent, I can always bring in my log function. It's called a logarithm. Logarithm function. Okay. And that is used in calculating what? Exponents. So please, this is very basic still. The only thing is just the ratio. And it's an exponent. That's all. All right. Can I go to sum of sum of what? Geometric. Let me know if there's any question. Because the thing is, when we now look at the full question, we'll be revising all of this concept again. Sum of geometric. Before I show you the formula, let's try something here. If my first term is 1 and my second term is half, what will my third term be? Multiplied by half? 1/4. What is my fourth? 1/8. And 1 over what? Let's stop there. Let's add. What is T1 plus T2 plus T3 plus T4 plus T5 going to be? Let's add, please, which is going to be S5. Somebody's adding for me. Please, let's add S5. It's a geometric now. We cannot use arithmetic. 1 plus half plus 1/4 plus 1/8 plus 1/16. 30? All right. I'm just going to rewrite the formula. You're going to substitute. I want us to just use the formula. Okay. Here's the formula. Please, I want you to watch this. Sn is a into bracket r to the power n minus 1 over r minus 1. Let's try it. What's our a? 1. What is our r? All right, 0.5, or we can say half. How many times are we adding? 5 minus 1 over what? Half. Please put this in your calculator. Just want us to use that formula. Use the formula first.
1 minus
You got it? Let me know if you got it, just to see that formula. Did we? Whose hand is up? Yes?
Sorry, sir. How did you get half?
What is your ratio, Kwesi? How do you get ratio?
T2 minus T1.
Ratio, not difference. What is your
T2
ratio?
over T1.
What's your T2? Half.
Half.
Don't make that mistake of difference and ratio. I emphasize that.
Yes.
Did we all substitute, guys? Did we all substitute? What do you mean 3 over 2, Chuku? What do you mean? Where's 3 over 2? I'm seeing your message. You said 3 over 2.
Oh no, sorry, sir. Sorry, sir.
Okay. And here, R must not be equal to 1. Do you know why? No. If R is equal to 1, what happens to your denominator? It becomes a 0, so it's undefined. So that goes with the formula. This is 31 over what? 16. I want you to try something for me. Please watch, everybody. I want to show you something quickly. What if I write the formula like this? 1 minus R to the power n. I don't know if you see a difference. I have switched it now. Okay. What is my A? 1 minus half to the power of 5. Let me use the block bracket there. I'll tell you something as we continue here. 1 minus half. What will that give us? Will it still give us the same answer? Will that still give us the same answer?
Yeah.
Give me a response, those of you at home. Will they still give us the same answer? Okay, so now you know how to use the formula. Are we okay? We know how to use the formula. We just substitute. What do you look at the formula? You need your A, your R, and your N. You're done. Are we okay with using the formula? Everybody okay? Let me know before we move forward. Let me know before we move forward. Just using the formula. The problem comes now. You have to prove this formula. You have to do what? Remember, we proved the arithmetic. It's 4 marks. We must also learn to prove. Yes, the formula will be given. It's on the formula page. I'll be showing you the formula page shortly. It will be given, but then they ask you to prove. All right. Okay. How do we prove the sum?
From term 1.
Yes, from term 1. From term 1. From day 1, you must ask your teacher for the formula page. Okay. Proving Sn of a geometric. Okay, please, I want you to listen. Don't write yet. I want us to see what to do here. And I'll show you a trick. I don't cram this formula. I just remember the trick. What is Sn? It is T1 plus what? T2 plus T3 up to what? Tn.
Yes.
We're proving for a finite. Okay, hold on. I did mention never work with T's. Change it into A's and whatnot. So since this is a geometric, can we change this? A. What is T2? AR. Beautiful. What is T3? All right. So many of them. What's the last one? I just interpreted. Now here is the instruction. Since it's a ratio, remember for the other one we were adding and subtracting. Now ratio we do what? Multiply. I am going to multiply equation 1 by R. Multiply everything by what? R. What is R times Sn? R, Sn. What will this be? AR. What will this be? AR squared. What will this be? All right. Plus AR to the power what? N. I don't know if that makes sense. Laws of exponents. Check this. Multiplied by what? R to the power 1. What do? Keep the base and add the exponent. So this forms my equation what? 2. Please don't write yet. Equation 2. Now, next instruction would be equation 2 minus equation 1. I'm going to subtract the left-hand side and subtract the right-hand side separate. Please watch this step. What would I have? RSN minus SN. That's the left-hand side. Look at this one. I'm going to write the whole thing in full. What do I have? What's my equation 2? AR plus AR squared plus AR cubed plus AR to the power N minus, can I have my equation 1 now? What do I have? A plus AR plus AR squared plus, all right. Let's be mathematical. If I expand that bracket, what do you notice? Let me expand it just for you. I don't want to, because if I'm at school, I won't expand. All right. But I want to accommodate everybody. Wait, hold on. Let me do something. What is the term before AR to the power N? ARN minus 1. That's the term before, just to show you. You see where I'm going, right? Now, let's expand this. What we're going to have? Minus A minus AR minus AR squared minus AR to the power. What do you notice? Something magical is going to start happening. The AR would cancel the AR. The AR squared will cancel the AR squared. What does it mean? The AR cube will also cancel the, such that this will also cancel what? That. What are we left with? RSN minus SN will be what? AR to the power N minus A. What is common on both sides? What's common on the left-hand side? SN is common, right? What do we have? R minus 1. What's common here? A. R to the power N. Divide both sides by what? R minus 1. Remember, we are looking for SN. Therefore, what is SN?
Oh, there's your.
Then that is my formula. And you are expected to know this. Formula pitch is given, but the proof you should know.
It's easier though than
Really? I'll show you how to do this without stress. Just write this down and I'll show you the little trick. Yes, are we done with writing the proof? Are we done? Okay, let's make it fast. And I'll show you what you can write down as a proof so that you don't stress so much. This is too detailed. I'll show you what to do. No, it's the same one, but you are allowed to remove certain things. But I didn't want to remove, you see, like this line where I was canceling, you don't have to show it. But I'll show you how to remember as quickly as possible. That's what I do. All right, the proof is on the group. Thank you, sir. So we save time quickly. We save time. All right, here's my trick. Everybody check this. Examiner says prove that Sn is a r to the power n minus 1. Please watch this. Count 7 lines and write the answer. 1, 2, 3, 4, 5, 6, 7. Start by writing the answer. No one is going to know. So here's the idea. You work back upwards. So for every operation, you reverse it. Check that. What do I do? Cross multiply. So let's cross multiply. What are you going to get? Sn into bracket r minus 1. Expand now. What do you have? R times Sn. Rsn minus Sn equals to what? A r to the power n minus a. Now you know that there are two equations already, Rsn and Sn. So you start by writing your Rsn and then you write your Sn. What's your Sn? A plus AR plus AR squared up to the last one, ARN minus 1. Equation 1. What is your RSN? You are multiplying, right? AR squared plus AR cubed, plus what? ARN. Equation what? 2. Then you come here and put equation 2 minus 1. You are done with the proof. 4 marks.
It's a smart way of doing it.
Yeah, you don't need to cram. Now I went from the total. You'll understand what I did.
Yeah.
But this is what is marked. It's 4 marks. 4 marks. If you check, you get 1 mark for equation 1, 1 mark for equation 2, 1 mark for subtracting, and 1 mark for factorizing. Because they said you should prove that. They're not going to give you an answer for anything you prove. Did that make sense? But remember, R must not be equal to what? 1. Easy to remember? I just count 7 or 6 lines down, start from the bottom, and I know I'm what? Reversing my operation. So I don't cram this in at all. All right, guys, we're good. Everybody good? Everybody okay? You can do that, you know? When they say proof, you must just pray that this one comes in the exam. No, unfortunately, you cannot do this for the other one. All right. Can I move on quickly? I want to look at the last 2 points, sum to infinity and convergence. And then we're done with just hit questions now. There's a lot of questions here that I need us to do. Sum to infinity. Okay. Sum to infinity. We only do this for geometric. Here, there's a proof, but you will not be asked to prove it, so I'm not going to prove it. All right. There's a way of proving this, but we don't need to prove it. This is saying you have T1 plus T2. There's no Tn. Make sense? It's called an infinite sequence. No, infinite series. Infinite what? Series. Or infinite geometric. Let's put the word geo. because we only do this for geometric.
But it could work for both.
No, for arithmetic, no. You see, because geometric is a fraction. You would see what I'm going to say as we go on. It's going to get to a point where we call converge, where an addition of the next term will make no impact. Or you'd see it just now. All right. Here's the formula, guys. We don't need to stress. S infinity is simply A over 1 minus R. You just use it. Is that okay? You just what? Use it. Yeah. Good. This formula looks familiar. Please, this is I now want to teach you a little trick. This formula looks familiar to this one. But please now, this is now innovation. But Sn can be written as what? A 1 minus R to the power n. Please watch. Do you remember we proved what? Rn minus 1. You do this one by saying equation 2 minus equation 1. But if I say equation 1 minus equation 2, I'll be getting this one. That's why both of them worked. The first one, the common one is 2 minus 1. But please know we can also use 1 minus what? 2. Here is the deal. And I'm going to show you a question on this one. Look at this. What is this?
So, positive and negative gradient one.
Now, it's sum to infinity.
This-
Do you notice this can be written as the
Yes, infinity, yes.
This is a little trick. A over 1 minus R into 1 minus O, which means Sn can be written as what? S infinity 1 minus R. This one is not on the formula page, but it's a shortcut to get so many questions answered. The examiner will give you some to. Let me create one quickly while you're writing. Please write that. I'm going to create one. Let me create one quickly. Can I borrow that calculator quickly? All right. Please write that quickly. And I'm going to show you how we can use this. I'll be with you now. Okay, here. Let's write this. I've got a question that we're going to quickly apply now ourselves. All right. Are we good? Okay, here's this question. I want to just pose this question for you, and let's see how you are going to respond. The sum to infinity of an infinite geometric series is 4. The sum of the first 5 terms is 31/8. Find the ratio. The sum to infinity of an infinite geometric. I told you what's important, guys, is to convert the statement into mathematics. All right? The sum to infinity of an infinite geometric series is 4. The sum of the first 5 terms is 31/8. Find the common what? Ratio. Let's change it into maths. The sum to infinity, S infinity, is what? 4. What is the formula for S infinity? A over 1 minus R equals to what? 4. Look, I have A and R, so I can call this equation what? 1. Then the examiner says the sum of the first 5 terms is what? 31/8. Let's write the formula. What would it be? A R to the power what? N minus 1 over what? R minus 1 equals to what? 31/8. But I know my N. What's my N? 5. So it's a matter of now trying to play around and working out mathematics. Okay? Equation 1 and equation 2. Guys, do you notice I have moved from English now to maths? Let's try to solve together. And we cross multiply. This is over 1. What is this? A will be what? 4 minus 4R. Okay? Can I take that and throw it here? Maybe it would help. All right. But hold on. If I don't multiply it, I want to see something. If I don't multiply, what would it be? 4, 1 minus R. Now, let's bring that here. What would I have? Instead of writing A, what should I write? 4, 1 minus R, R to the power 5 minus 1 over R minus 1 equals to what? 31/8. Let's try to solve. I don't know if you see sign change there. We did that. We did a question that required that. If I put a negative here, 4, I could then write this as what? All right. R to the power 5 minus 1 over what? R minus 1 equals to 31/8. I've done sign change now, right? We spoke about this in our second lesson. Make sense? So what do we have? Let me write that out.
Oh, I see why you never distributed.
Yes, so we can cancel that one out, right? R to the power 5 minus 1, 31 over. Can we divide both sides by -4? What would that be? R to the power 5 minus 1 will be equal to what? -31/32. Now, can I move the 1 over? And that would be what? 1/32. Now, what is R? It is the 5th root of 1/32. R is half. Let me know if you got the whole process. Divine, you used a different formula, a different way, and got the same answer. Beautiful. That's me. As long as you're not breaking maths principle. But I wouldn't do this. I wouldn't do this. This is too long. I would not do this. This is too long. Question is, what would I do? What would I do? All right. Please just take a picture of this and send on the group so that we can save some time. I want to see if we can finish at 7. 7. Who's fetching you? At what time? Tell us 7. No, tell us 7. All right. Okay. Thank you. I think a picture. I just said my phone ring. Okay. A picture. Thank you, sir. All right. What would I have done? What would I have done? I'm going to reproduce this page. Oops. Sorry. I am going to reproduce this page and watch what I will do. Remember, I'm going to give you questions to also practice at home now, right? Okay. Look at what I will do. And remember that my S infinity formula is A over 1 minus R. I'm using 1 minus R, right? So what is my Sn? I'll use the 1 minus R. So it is 1 minus R to the power n. So I know my Sn is what? S infinity.
1 minus R.
Now that's going to be my joker. What is my Sn? I know my n is 5. That is what? 31 over 8, 4. Talk to me. Somebody's raising a hand. Yes, Kwezi. Yes, Kwezi.
Sorry, sir. So within the previous equation, you had by the denominator you had r minus 1. Now it's 1 minus r. It doesn't matter if it changes the sign.
Kwezi, are you snoozing today?
Yo,
Huh? Are you snoozing today? I explained the 1 minus r and the r minus 1. I said it to give you the same formula, the same answer, right?
yeah.
One you get from saying equation 2 minus 1. The other one you get from saying equation 1 minus 2.
Yes,
Are you with me?
yes, I am with you. Okay, I see. Nice.
Good. So 1 is equation 2 minus 1. 1 is 1 minus 2. But it will give you the exact same answer. That's why I wanted us to try it at the beginning. All right?
Okay.
And I'm now using if I'm using my sum to infinity, I notice my sum to infinity is 1 minus, not r minus 1. Please write it well from the formula page. So once I see I'm using 1 minus r, I am going to the formula that says 1 minus r. What do we do here? Divide both sides by 4. That is what? 31 over what? 32. Move the r over, it becomes what? Positive. I don't know if you see that we're already there at the final step. So what do we have? R to the power 5 is what? 1 over 32. The fifth root of 1 over 32. So this formula here, already I have done the simultaneous for you. Okay, what's that going? If you remember and know how to use this formula, I have already done the donkey work of the simultaneous for you. But remember, if it's s to infinity, it is 1 minus r to the power n. Did that make sense? Great. That's what you did, divine. Sweet. That means you were following me. Beautiful. It's kind of concise, short, and you found out in 6 months.
I don't give you this.
It's not there on the formula page. So it's an innovation that we did to see, okay, how to merge sum to infinity and Sn together. All right. So if you know this, otherwise you will be using this one.
The same thing.
Yes, it's the same thing. It's just longer. You'll get it right. Okay. But now in grade 12, time is of essence. All right. So guys, that's how we deal with Sn and S sum to infinity. Let's see. One more thing and then we're done. Okay. Then we can look at, I want to look at least 2 full questions with you, then allow you to go practice using all the, you're not going to find anything different from what we've done. Everything will be done. All right. Convergence and divergence. Convergence and divergence of S infinity. Sum to infinity converges, that is, add up to a number such that an addition makes no impact. I'll tell you what I mean. An addition of the next term makes no difference. If I tell you, look at this. What is 10 plus it makes no mathematical impact. That's what we mean by
You get to a point where there's too many zeros.
yes. You get to a point where the next term that you're adding really makes no difference. Remember when you say times half, you are basically dividing by 2. So the number becomes smaller and smaller and smaller and smaller. All right. This occurs when R is between -1 and 1. Please take note. And that's the key. So S to infinity converges. It's called convergence. When R, and that's the condition. So every time we get R to be that, it will converge. Oh, it means it will what? Diverge, which means becomes bigger and bigger. When would that happen? When R is greater than 1, it's I don't know if you see that it's inequality. And R is less than -1. It's an inequality. If we draw our inequality number line, what do you notice? -1 and 1. Here, S to infinity converges. Here, S to infinity what? Diverges. And S to infinity also does what? Diverges here. So when your R is bit, and this represents the value of what? R. When R is between -1 and 1, what happens? We talk about convergence. Any further addition makes no difference. All right. It's like somebody with R1,000,000 and then you give them 50 cents. They just look at you. Are you okay? Are you all right? You know? Are you sure you want to give me that? Okay. Are you sure? Somebody who is a trillionaire, and then you give them R100. Like, are you sure you want to do that? Are you sure you want to do that? Say, yes, sir, I want to do that. Okay, all right, no problem. So, please, this condition is very important. You have your convergence and your divergence. Mostly the questions are on convergence, but I've seen questions where the examiner asks you, for which value will it not converge?
You're saying the divergence. So just like that.
Okay, I'll show you an example. Let's try to do a question together. Are we done writing? We'll look at a question together. Basically, look, we are almost done. All right, let's see how examiners are going to throw these questions at us. We look at one full question or two and then see how to tackle them. Okay, look at this one. I think I have one full one here, 12 marks. All right, I'm sure, look, the first three, you can do them. Let's start from the first one. Everybody, it says, given the geometric sequence, please always make sure you read. Identify the type of sequence. That is key. It's geometric. So what do I know? The ratio. You want to get me the value of B? Everybody, let's walk through the value of B. 3 marks quickly. Value of B. Let's work that out. You do it the way we did the N. T2 over T1. All right. That's one way. Or you can get R directly by saying T3 over T, whichever way. Come, let's get the value, possible values. Read very well. Possible values. Yeah, I think everything we need is in this. Everything we did today is right in this question. Minus 1 over 4B and -1. Answer? Let's mark. -1 over 4 B. Look at what I would do. I would say I know that my R is what? T2 over what? T1, which is something as T3 over what? T2. What is my T2? B over what? -1 over 4 equals to what? -1 over B. What would I do now? Cross multiply. What do you get? B squared, negative times negative, positive. What is B? Plus or minus. We said it's an even root. That's why the examiner says possible. They didn't say value. Values. English. That's my first one. So please take note, I gave you that rule. If it's an even root, plus or minus. Even if it was a 4, I would have said plus or minus. A 6, plus or minus. 8, plus or minus. All right. I hope that makes sense, everybody. Let me know quickly. Yes. Algebra. Oh, I forgot that my YouTubers are here. Okay. No comments and questions so far. Crazy. It's not 1 over 2. It's plus or minus. Please always read the question. Look at, let me show you something. Emphasis. It's hidden. All right. Now look at number 2. They're saying if B, find the what? 19th term of the sequence. Okay. How do we get T19? We know T19 should be equal to what? AR to the power 18. We can go there straight. What is our A? -1 over 4. What is our R? We are told that 1 over 2, 18. Please use your calculator and let's get an answer. There, we're done there. Sweet, sweet maths. It's a big answer. Don't worry. Give me the fraction.
10 million. No. 1,048,500.
Okay, it's 10.
10485
5.
76.
That's all.
Yeah.
Okay, done. Easy. Guys, are you okay with that? Are we okay? Just trust the process, trust your calculator. Let me know. Only Zoe giving me a response there. Only Zoe is giving me a response. I need to know if we are okay. Kwesi also gave me that answer. Come, what's wrong? Megan, Kenneth, Cizwe, Divine. Okay, now I'm getting thumbs up from everyone. Number 3. Let's look at number 3. What are we looking at? If B equals to half, write the sum of the first what? 20 positive terms. It means we have to extract our positive terms first. All right. If B is half, positive terms. What are the positive terms? Positive terms. Okay, wait. What do we have? -1/4 if you are not sure. What is B? We are told half. What is C? -1. If you see, automatically I see a sequence there. What do you think the fourth term would be? Yes, Kwesi, your hand is up.
No, sir, it's okay. Sorry.
Okay. Megan, you joined late. You see, I told you that if you join late today, what is our R? What's our R here? T2 over what? T1. What would that be? Half divided by what? -1/4. What's your answer? You want to do what I did? It's -2. Yeah, because it's 1/2. So if you keep multiplying by negative, so what do you notice? T1 is negative. Multiply by negative, you get a positive. So which terms are going to be positive? It is your T2, your T4, your T. So let's extract that out. Positive terms will be what? Half. What's going to be our next positive term? No, 2. Because we are multiplying each term by what? -2. -1/4 times -2 would give us half. Half times -2 would give us -1. -1 times -2. So we are dealing with T2, T4, T6. Beautiful. We're done. What is our ratio here? One over 4. Is it? You sure it's 4? Yes. 2 divided by half, which is what? Okay. So what is our Tn going to be? Remember, a to the power r minus 1. What is our a? We are using this sequence, my dear learners, now. 1/2. What's our r? 4. Now, what's our sigma? They said, how many times? Is it 20 or 19? 20. Beautiful. So what would it be? We put our Tn here, right? Remember? And what do you have? N equals to what? 1 sigma. So there's no need to waste time on sigma again. We spend so much time on it. We follow the same process. Guys, let me know if it makes sense. Positive terms. So we need to extract your positive terms out of the entire. Yes, Zoe, your hand is up.
Was a mistake, sir. Sorry.
Are you okay?
Yes.
It makes sense, right? So our positive terms are your T2, your T4. So we follow the same order of sigma Tn, n equals to the first position and the last position. Boom. Done.
Oh, the same.
Yeah, the same rules apply for both arithmetic and geometric. Okay, let's look at the last question on this one. Is this geometric series formed in question 2.3 convergent? In 2.3, give a reason for your answer. What is the rule of convergence? R must be between -1 and 1. Now, in 2.3 is this one, right?
Yes.
Okay. What is our ratio? No, our ratio is 4. So is it convergent? No, not convergent. Why? R is greater than 1. I'm done. If my R was between -1 and 1, then I'll say it's what? Converge. Guys, do you understand the condition? We are done there. Yes, Kwesi?
Sorry, sir. Within the previous question, is a half, is it our first term?
Read the question again. What are we looking for? Write down the sum of the first positive 20 positive terms. So we have to extract our positive terms. And this is the one we are using. We're no longer using 1/4, -1. Negative is not positive. These are positive terms.
Oh, so it's -2. We can't choose. Okay.
These are positive what? Terms. So my A is now half.
So we had to use half because 2 is -2.
No, which sequence? The question is, which sequence are we now using?
Mm.
We are using the sequence of positive terms. So what's my first positive? Half. What's the second positive? 2. What's the next positive going to be? I think it's 8. Do you understand what's going on there?
How did you get 8, sir?
Okay, always read the question. Write down the sum of the first 20. What type of terms are we dealing with?
With positive.
Good. So what are your positive terms? You're no longer dealing with everything. What are your positive terms?
Half.
Okay, let me help you here. Check. Let's write these terms. Maybe it would help you there. Let's continue these terms. All right. What was the original term? It was -1/4, right?
Yes, sir.
Half. Do you remember what we did?
Yes.
We are multiplying. What's our ratio there? Our ratio is half, right?
Yes, sir.
We're multiplying by. What are we multiplying by again? No, our ratio is -2.
Yeah.
Kwesi, are you with me?
Yes, sir.
R is what?
Negative.
-2. Okay, so what is -1/4 times -2?
-1/4.
Yes, times -2. Let me allow you do it. Divine, I'll come into you.
Half. Okay.
Good. What is half times -2?
-1.
Can you see we are back at our term? What is -1 times -2?
2.
What is 2 times -2?
-4.
What is -4 times -2?
-8. No,
Ah.
+8. Sorry.
Aha. So can you see we can continue like that, right?
Yes, sir.
So what are your positive terms? Because we are dealing with only positive terms. What would it be?
2. Sorry, half, 2, and 8.
Half. Next.
2
Next.
and 8.
So we want a sigma for this. So what is your A?
C.
Huh?
Half, sir.
Good. So we are now working with this sequence. This is the sequence of positive what? Terms. And my R is T2/T1 or T3/T2. Can you see 8 divided by 2 will give me what? 4.
Yes.
So you've got to read the question, understand what the examiner is looking for. All right. Divine, your hand was up.
Thank you.
Sir, so I had a question, and concerning the third question that we just did. So they said
Yes.
write it down in sigma notation, right?
Yes.
So wouldn't we be required to add the equal sign and actually add those terms and then get the answer, or do we just write it in that? Like, how would we know when to equate it?
The examiner will tell you to evaluate.
Oh,
If I say evaluate this one, it means give me an answer by adding all the terms. Give it a value. Evaluate.
oh, thank you, sir.
You are most welcome. All right. Any other question there? Oh, it's already 7. Any other question? Okay, let's see what questions I'd love you to, just practice. Okay, let's start taking pictures, please. This one is very straightforward. Very. Determine n. It's a geometric. You can already see your ratio is 1/3. Calculate. Can you see this one? What formula are you going to use for 2.1.2? They said 30 plus 10 plus 10/3 plus 3 dots. What is that telling you? Infinity. This is infinity. So no one is going to give you that word. So here I know I'm dealing with S. Infinity equals to what? A over. Can you see it's 2 marks? You know your A, already you know your R. Throw that in. Okay. Somebody sending me a picture. I'm just taking note. Let's see if we can get 5 questions to do. 5 questions. All right. This one is in, number 1. I'm just checking on my phone to see. Beauty. Oh, this is one is looking yummy. Now, can you see this one? This says evaluate. If you look at 5.2, okay, prove. Look at the one they ask you to prove. No.
So when you showed us.
Yes. But the one I did was what? R minus 1.
Versus 1 minus R. So you
But
just put it as your answer.
Yes. Put that as your answer and work back upwards. 6 marks for free. Given the geometric, explain why the series converges.
So work out the ratios.
Work out the ratio, check if it's between 1 and -1. Evaluate that. Can you see it's sum to infinity? It's an infinity sum there.
Yeah.
All right. What do you need? You need your A, you need your R.
Yeah.
So to get your R, please, my dear learners, to get R, first get T2 and then get what? T1. Please be that one is very tricky. Get T2 first. You know how to get T2.
You can't use
No.
5.2. RA from 5.2.
I'm not sure if it is the same. All right. Okay. The sum of the first n terms of sequence is given by that. Guys, we did this. How do you get sum of the first 24 terms? Just throw in 24. How do you get the 24 term? T24 will be what? S24 minus S what? 23. Okay. Proof that the nth term of the sequence, you are looking for Tn. We did this as well. All right, beautiful. Do we have this? Yes, we got this. Beautiful. Let's just take 5. Number 3. Oh, sweet one. I love this one. Given the geometric sequence, can I do this one quickly, please? Let's do this one. I was looking for something like this. Let's do this one together. Determine the value of x. This is very important that I do. For which the series would what? Converge. What is your rule for convergence? Rule for convergence. I'll just do 2.2.1. R must be between what? -1 and 1. But what is your R? R is T2 over what? T1. What's your T2? X squared minus 4 over what? X minus 2. I don't know if you see this as difference of 2 squares. X minus 2, X plus 2 over X minus 2. So what is our R? All right. Remember, we are looking for the value of what? We are looking for the value of X. For convergence, check that. That's my rule. But what is my R now? x plus 2.
Oh,
Make sense?
yeah.
What do? Subtract 2 from every, just move 2 to this side, also move 2 to this side. So negative, grade 8, you remember that stuff. So what's your answer? Negative 3 less than r less than what? Negative 1. That's the value of x. Easy question. And I'm sure if x is negative, you can calculate the sum to infinity of that.
For 2.2.1, you can't say T2 over T1 is equal to T3 over T.
No, you need your r. You have to. We're not really looking for the value of x. We are looking for the value of x for which that will convert. So we have to bring it into this restriction. All right. Do we have this? So I did the first one. Okay. Please take a picture of this again so we can just continue with the solution. With the solution. So we take it from there and then we can find sum to infinity. Thank you. So far, so good. We are done with 4 weeks of work. Oh, application. Please take this one. This is number 4. Application. Application. I'm not going to explain this. I want you to try this. Read this. Application. Talks about a tree growing, a bonsai tree. Then we take the last one. Thank you, sir. We have the last one. Chips. Look at 1.1.2. 7 marks. All right. Guys, let's walk through these 5 questions. I'm sure it will stretch you a little bit. Yeah, there's a key there. First 50 terms. I want you to try. This is now grade 12, no more spoon feeding. So I want to train you so you're ready for anything the examiner brings. So you see, we've done a few things. I promise you there's nothing new here. It's the same principle. But first, you need to interpret the question and apply the principle. So right now, I'm training you on interpreting. You don't just apply. You have to interpret first. Guys, how was the session for you? Did it make sense? Did it make sense?
Next session is good. Come on. Get the last
one. Yeah, we have one more. Wait, guys, I've got lovely questions here. But don't let me kill you. Look at. I think some of these let's do together. All right. Let's do it together. All right. So let's deal with those 5 questions. We start with those 5 questions, and then we start working. Once we get a bit of confidence, we walk through other more difficult questions. This is why you prefer arithmetic, divine. Sorry, arithmetic is grade 8, divine. Guys, have a lovely evening. Have yourselves a lovely evening. Tomorrow, I think, tomorrow is the 4th session, right? Yes. So please, you've got work to do tonight. Run through this. By tomorrow, we're done. We know we are done with 4 weeks because the last one is quadratic, which is just revision. Just revise. Same quadratic, nothing different. Same quadratic, but link it to functions. Yeah, like, yes. Now that's 4 weeks of work done, which means we can safely then go to topic 2, which is functions. Let's have a beautiful evening. All right, bye guys. Bye, bye, bye. Lovely, lovely evening, everybody. Good night. Good night, good night, good night, everybody.